Assalamualaikum and hi. My name is Ahmad Taufik bin Muhammad, matrix number 24 Dam 18F 1091 with my fellow colleagues Alif Aiman bin Suzanizam 24 Dam 18F 1074 and Muhammad Amrul Fitri bin Ismail 24 Dam 18F 1090. And today we're going to present about chapter 6 Pneumatic and Vacuum, aka chapter 36 and 37. Generally, pneumatic systems are fluid power systems that use a compressible fluid air. It is dependable and also lightweight. It doesn't need a return system. It has low pressure pneumatic system is needed to operate the gyro instruments. Compressed air as an emergency backup for lowering the landing gear and operating the brakes in the case of hydraulic failure. And the last one is it actuates the landing gear retraction, nose, wheel steering, passenger doors, and propeller brakes. Safety precautions. When working on a bleed air systems, it is important to follow the precautions below. Bleed air is hard. Do not touch pipes and ducts. Always replace seals when replacing joints. Tighten clamps to the torque figure quoted in the maintenance manual. Never lever against ducts as dents cause hot spots. All duct supports and struts must not put any strain on the duct. Fuel pneumatic systems. The majority of aircraft use hydraulic or electrical power to operate landing gear systems, but some aircraft use air systems. Some advantages of using compressed air are air is universally available and in unlimited supplies. Pneumatic system components are reasonably simple and lightweight. No return lines are fitted, resulting in a weight saving. There is no fire hazard and the danger of explosion is slight. Contamination is minimized by the use of filters. Figure 1 shows a typical high-pressure pneumatic system that uses air compressors driven from the engine accessory drive. The pressure relief valve maintains system pressure at around 3000 psi. A shuttle valve in the line between compressor and the main system makes it possible to charge the system from a ground source. Moisture in a compressed air system will freeze as the air pressure drops when the component is actuated. To prevent this, a water separator is fitted which collects the moisture from the air onto a baffle and it is allowed to drain overboard. Any remaining moisture is removed as the air flows through a desiccant or chemical dryer. Air is then fed to each of the storage bottles that provides emergency air for several systems. A manually operated isolation valve allows the maintenance to be carried out without discharging the storage bottles. A pressure reducing valve is fitted to reduce the air pressure down to the operating pressure that the majority of the components work at ground 1000 psi. A vacuum system. A supply of air at a negative pressure. Supply of vacuum to instruments attached to the piston engine of the aircraft or from a venturi jet pump. Other source of requirements of vacuum is the pneumatic de-icing system. Ensures that the boots are sucked flat onto the wing leading edge, ensuring a smooth aerodynamic surfaces. Low pressure pneumatic systems. These systems provide air for gyroscopic altitude and direction indicators and air to inflate the pneumatic de-icing boots. This compressed air is usually provided by a vent-type engine-driven air pump. The engine-driven air pump is used primarily to evacuate the casings of air-driven gyroscopic instruments. Discharged air was used to inflate the icing boots on control surfaces. Two types of air pumps that are used. These are wet air pumps and dry air pumps. Wet air pumps have steel vents that are lubricated and sealed with engine oil. Oil is removed from a discharged air with an oil separator before it is used for the icing or driving the instruments, while dry air pumps no oil in the discharged air, and therefore there were no requirements for an air separator. Pump vanes are made from carbon and are self-lubricating, easily breakable by any contaminants that enters the pump. To prevent this from occurring, the inlet air is filtered. Air supply source. The source of air supply and arrangement of the system components depend on the aircraft type and system employed, but in general of one of the following methods may be used is engine bleed air, used in turbojet aircraft in which hot air is bled off from the engine compressors to the cabin. Two tappings are taken from the engine, one from the low pressure stages and one from the high pressure stages to maintain a reasonable pressure band at all engine speeds. At low engine RPM, the low pressure air is of insufficient pressure from use in the pneumatic systems, so air will be tapped from the high pressure stages. When operating at maximum engine speeds, the air will be taken purely from the low pressure stages. Compressors or blowers used by some turbojet, turboprop or piston engine aircraft, the compressors or blowers being either engine driven via an accessory drive by bleed air or electric or hydraulic motors. When insufficient low pressure air pressure is available for the pneumatic systems at low engine speeds, the aircrew will select the shut-off valve to open. This will direct the low pressure air to drive the turbo compressor. On large multi-engine aircraft, only some of the engines will have a turbo compressor.
Auxiliary Power Unit (APU), an independent source of pressurized air. A small gas turbine engine that provides air and other service while the aircraft is on ground with its main engine stopped, located in the tail section of the aircraft where it can be run safely. On some aircraft, the APU can be stored in the flight and act as a backup source of air hydraulic service in the event of an loss of an engine. Ground supply. For use on the ground when the engines are not running, the compressor output pressure is regulated to match the aircraft system pressure. The maximum aircraft system pressure and operating instructions, including safety precautions, are detailed on the inside of the service access panel. Pressure control. The range of the pressure may be from 10 psi at ground idle to 65 psi at takeoff power. The pressure regulator is a pneumatically operated valve which will give a predetermined output pressure from the engine bleed air system. The regulator may also perform as the shut-off valve. This is then called a pressure regulating and shut-off valve. Pressure regulator. This valve operates on the principle of a balance between air pressure and spring pressure. A bleed orifice in the piston allows air pressure into the piston chamber. A relief valve being acted on by the reduced 200 psi pressure and relief valve spring pressure, maintaining the air pressure in the piston chamber at 750 psi. When the air supply is used by a pneumatic service, the reduced downline pressure of 200 psi reduced further. This reduced pressure is now insufficient to keep the relief valve closed. The 750 psi piston chamber pressure unseat the relief valve and reduce the piston chamber pressure. The reduced piston chamber pressure unseat the piston cone piston, which allow the system pressure to bleed into the downline. Once the downline pressure rises to 200 psi, the piston cone and the release valve reset and the system is once again in balance. Distribution. Distribution is achieved by ducting and pipeline that carry the charged air from the engine compressor to the various services that require air for their operation. Due to the heat of the bleed air, any leakage of the duct will cause an extreme temperature rise in the area of the leak with the possibility of fire or damage to the surrounding structure and equipment. Leak detection systems are therefore incorporated. The ducting is made up of many sections for ease of maintenance and cheapness of replacement. They are constructed of thin wall material and clamped together with joints that allow for thermal expansion. Engine bleed air system ducts are manufactured from stainless steel, and the duct and pipeline are usually manufactured from titanium, as they are able to withstand higher temperature and are lighter in weight. The duct sections are supported throughout their length by clamp and tie rod attachment to the aircraft structure. Expansion joint. Joints are assembled cold, and when in use the temperature is in the ducting can reach up to 350 degrees Fahrenheit. Expansion device must be incorporated into the system to prevent any distortion or buckling of the duct. This expansion can be allowed for in several ways. First is pre-stressed joint. One method is to have the duct section installed slightly shorter in length and allow them to expand with the heat to fit correctly. The duct will be pre-stressed by the clamp when cold. Flexible ball joint. Another method is with a flexible ball joint fitting at the duct end. The joint is designed to allow for slight flexing and misalignment as well as expansion. Cable attachment joint. The cable attachment type joint is used where large temperature change exists, from cold sock at high altitude to maximum working temperature when the pneumatic system is selected on. This joint has bosses attached at each end of the duct.
Flexible ball joint. So it is designed to allow slight flexing and misalignment as well as expansion. Next, cable attachment joint. It is used where large temperature change exists from cold soak and high altitude to maximum working temperatures when the pneumatic system is selected on. 1.9 Indication and warnings. Pneumatic services are generally selected from in the cockpit. Control panel will give a visual indication of the status of a system, on, off, not selected, as well as monitoring of any system pressures. System local fault will also appear on the control panel and will be duplicated on the CWP with associated lights and audio warnings. Overpressure. It is usually caused by a malfunction of the high pressure shutoff valve that remains open when the engine is operating at its maximum RPM. Overheat. An electrical temperature sensor. Temperature is reaches the electrical sensor will signal the high pressure shutoff valve to close. Duct hot air leakage. A duct protection system will include fire wire, elements around the hot zones such as engine air bleeds, air conditioning packs, and auxiliary power units if fitted. When the circuit is made, a warning signal is sent to the cockpit central warning panel with associated caution or warning lights and aural chimes. 1.10 System interface. Interfaces with various of other aircraft systems. The bleed air has been reduced in pressure to around 40 to 50 psi. Pneumatic gyro power system. Gyroscope in pneumatic gyro instrument are driven by air impinging on cups cut in the periphery of the wheel. Air pump suction. Air pump suction evacuates the instrument case and draws air in through a filter. The filter air directly through a nozzle and it strikes the driving cups to drive the gyro equipment. So this is the picture. Next, dry air pump pressure. The gyro instruments are driven by the air from the pressure side of a dry air pump. 1.10.2 Emergency landing gear system. On some aircraft, in case the hydraulic system fails, there must be provision for an emergency extension of the landing gear and application of the brakes. A pressure cylinder which contains approximately 3000 psi of compressed air or nitrogen. So this is a picture. Next, pneumatic de-icing system. It is compressed air system used for inflating de-icing boots. It uses wet air pumps. The oily air leaves the pump and passes through baffle plates in an oil separator. Oil collects on the baffles and drains down the collector at the separator base and returned to the engine oil sump, such as this picture. Next, air conditioning and pressurization. Blitz air supplies provide hot air to the air conditioning packs. Hot air passes through primary and secondary heat exchangers before it is mixed with cold air to provide conditioned air into the aircraft. Bleed air is also used for cabin pressurization. Air-driven hydraulic pumps. Some aircraft use hydraulic pumps operated by air turbines. The turbine is connected to the pump via a shaft and the air is exhausted to the atmosphere from the turbine outlet. Pressurizing of hydraulic reservoirs. Aircraft flying at altitude in excess of 20,000 feet require the hydraulic reservoir to be pressurized to prevent foaming of the fluid due to the low ambient air pressure and to prevent pump cavitation. Waste and water system. Toilet system fitted to larger aircraft use a vacuum to empty a number of toilets into a single collector tank. This saves having a self-contained tank full of deodorizing fluid and the associated pumping mechanism attached to each toilet assembly. Flush operation consists of fresh water from the potable supply. Only at low levels, when the outside air pressure is insufficient, is a small vacuum pump called into operation. So this is a waste and water system. Next, pneumatic stall warning. Slotted platter is mounted on the wing leading edge and its slot coincides with the stagnation point of the wing during normal flight. The slot is connected to a horn via a tube. When the angle of attack is sufficient to induce a stall, the low air pressure is drawn into the tube and sounds the horn, giving the pilot warning of an impending stall. Pneumatic engine starting. Bleed air generated from an onboard APU or from a ground car may be used to drive a starter generator for engine starting. Like this. So that's all from us. Thank you guys.